0.25 ampere. 0.25 ampere. Well, what does the resistance then equal to? What is 0.5 divided by 0.25? Is that 2 ohm? That is what I have put there. So 0.5 volt is the potential difference. 0.25 ampere is the current. Now I'm going to increase the potential difference to, let's see what, I'm going to increase it to 1 volt. All right, I have the potential difference is increased to 1 volt. I think you can read that. That is 1 volt. And now the current is, can you read that? The current is 0.5 ampere. So potential difference is 1 volt. The current is 0.5 ampere. What is the value of the resistance of this conductor? R equal to V over I, that is 1 divided by 0.5, that is 2 ohms. Let's try one more and see if I can make a potential difference of 1.5. Let's see if I can get a potential difference of 1.5. Well, it's about 1.5 there. There you are. That's about 1.5. What is the current? Well, we can actually make any number of studies. Every time the potential difference divided by the current will give you the value of the resistance. All right. Now, let me see if I can show you a computer animation. Now, this interactive exercise provides a selection of resistors. Look at this, 1 ohm, 2 ohm, 4 ohm, 8 ohm, 16 ohm. These are the available resistors, and you have cells that will provide a potential difference 18, 36, 54 and 72 volts. We can set up this circuit, and this circuit has a switch on off. It contains a bulb. The maximum current the bulb can take is 3 ampere. And this is the cell, and you can put the resistor here. You can create a potential difference by using the cell there. Now, tell me, I have a cell that will provide a voltage of 18 volts. And I have used, a resistor of 8 ohms. Tell me, will the bulb blow off? Well, actually I need to open that switch, is that right? Well, you can see the switch closing will not blow the bulb. Tell me, what is the current now in this conductor? Well, the current in this resistor will be the same as the current flowing in the bulb. You see, because you remember we talked about series connection. The bulb is connected in series with the resistor. That means whatever current flows in this resistor will flow in the bulb as well. Tell me, what will be the current that flows in this resistor? The potential difference is 18 volts, resistance is 8 ohm. So the current will be V over R, which will be 18 divided by 8, which is less than 3 ampere. So this is a safe current. Now tell me, what happens if I now replace this resistor by this 2 ohm? Let's do that. Let's take that 2 ohm and place it there and move that 8. Now, I have now opened the switch. What will be the current in that resistor or in the circuit? That will be V equal to 18, R equal to 2. V over R will be 9 ampere. Will the bulb suffer that 9 ampere? No, it will blow off. Let's try it. Close it. No, it's blown off. Well, you can actually play with this and learn a little more about Ohm's law. Alright, I'm going to close it. I have given you the website. Now, during my lectures, there are a number of very useful websites I have provided. In fact, almost all the web animations and interactive exercises are borrowed from useful websites, which you can access on your own. Alright? As I told you already, the current I in a conductor is measured using an ammeter. An ammeter is connected always in series with the circuit because the current has to go through it and through the conductor. The ammeter is connected in series with the conductor. Now look at a circuit. This is the battery, that's the positive end. This is the negative end, and I have used the lamp as the conductor. Now remember, the filament of a lamp is a resistor. It allows electric current to flow through. At the same time, it offers a resistance for the flow of current. So this lamp is a resistor. And how is it connected? Look at the way the ammeter, the resistor and the battery are connected. This kind of a connection is what we call a series connection. In other words, end-to-end connection until we complete the circuit. The positive end of the battery to the ammeter, the other end of the battery, the other end of the ammeter to the lamp, then the lamp back to the battery. This is a series connection. So an ammeter is connected in series with the circuit, and we use the symbol shown here. Look at the symbol for the ammeter. A circle with an A is an ammeter. Well, in order to measure the potential difference, you see, this is the resistor we have. The current in the resistor is because there is a potential difference between the ends of the conductor. Now what we need to do is, we need to measure the potential difference between the ends of the conductor. So what do? We connect a voltmeter between those 2 points where you want to measure the potential difference. A voltmeter is always connected between the 2 points where you want to measure the potential difference. So a voltmeter is actually connected in parallel. You see that? Now how will you connect the voltmeter if you want to measure the potential drop across the lamp? We want to measure the potential difference or potential drop. Now, does it make sense to call it a potential drop? One end is a high potential point, the other end is a low potential point. There is a potential drop along the length of the filament. How will you measure it? Now, this is the voltmeter. You connect it between the 2 ends of the conductor. And this is a parallel connection. An ammeter is connected in series and the voltmeter is connected parallel to the conductor. Alright, let's do a small problem. A light bulb has a resistance of 240 ohm when operating at a voltage of 120 volt. What is the current in the filament? Well, you have the value of the resistance, you have the value of the potential difference. Therefore, we can calculate the current using the Ohm's law relation. V equal to Ri. Therefore, I equal to V over R. That will be 120 volt divided by 240 ohm. That is 0.5 ampere. Very simple calculations. Let's do a couple more of those very simple calculations. What is the resistance of an electric heater which takes a current of 15 ampere when connected to 120 volt supply? So we have the current, we have the voltage, we need to find the resistance. So we can go directly onto that equation. if V equal to Ri, then R equal to V over I. Is that right? So V is 120 volts, I is 15 ampere, and the resistance of that heater is 8 ohm. Alright? Find the potential drop across an electric bulb if the filament that has a resistance of 240 ohm carries a current of 0.5 ampere. This time we have the resistance, we have the current, we need to find the potential difference. Potential difference is the same as the potential drop. V equal to Ri. So knowing the values of R and I, we can calculate the potential difference. Well, I'm going to stop this part of the lesson here. I'm going to continue in the next part, a study on resistance. We will talk more about resistance of a conductor. Alright, I will see you that in a minute.